Welcome, travelers, to Adventures in Security. In this video, we explore the purpose and importance of root cause analysis. And 3 approaches to determining root cause. You can download the video script with bibliography from the link below. Picture this. Your team fixes an outage, everyone celebrates, and then the same outage returns next week. That's a symptom trap. Root cause analysis, or RCA, is how we escape it. RCA doesn't mean blaming people. It means understanding the system conditions that made the failure possible, and then changing those conditions so the problem doesn't repeat. In this video, we'll cover 3 of the most useful RCA methods you can learn fast and use often, the 5 whys. The Fishbone, also called Ishikawa, or cause and effect diagram. And fault tree analysis. Each one is a different lens. One drills down, one fans out, and one models failure logically. To keep things concrete, we'll use the same scenario throughout. During a flash sale, an e-commerce checkout starts returning errors and customers can't pay. By the end, you'll know how to run each method, plus when not to use it. Before we touch any RCA tool, we need good inputs. Step 1 is a measurable problem statement. What happened, where, when, and how big? For our example, from 2:05 to 2:17 p.m. Eastern, 38% of checkout requests returned HTTP 500 during the flash sale. That's specific enough to test. Step 2 is a quick timeline backed by evidence. Logs, metrics, alerts, change history. Step 3 is discipline. Separate facts from hypotheses. Database CPU hit 95% is a fact. The database was overloaded because marketing is a guess until proven. Also remember, many incidents have multiple contributing causes: code, configuration, monitoring gaps, decision-making, training, and more. RCA is about improving the system, so we avoid the root cause is human error as a stopping point. Finally, don't implement fixes based purely on a diagram. Use the diagram to generate testable causes, then validate with data or experiments. Why do teams love 5 whys? Because it's fast, easy to teach, and it often produces an action you can take today. It's especially strong when the problem really is a mostly linear chain. One dominant pathway, from cause to effect. But here are the downsides. Complex systems rarely fail in one straight line, so 5 whys can miss interacting causes. It's also sensitive to facilitator bias. The group can steer toward a favorite explanation. And teams often stop early at a convenient cause, like, we need more testing, without identifying what to test or why it was missed. Now, our example. Problem. Checkout returns HTTP 500. Why? App servers timed out waiting for the database. Why? DB hit max connections. Why? Connection pool size was left at the default after scaling the app. Why? The deployment checklist doesn't include verifying pool settings and load tests after scaling changes. Countermeasure. Add a scaling runbook step, plus an automated config check and a pre-sale load test tied to a go/no-go gate. Next is the Fishbone diagram, also called Ishikawa, or cause and effect. If 5 whys drills down a single chain, Fishbone spreads out. It helps teams systematically brainstorm many possible contributors and organize them so you can see patterns. You start by writing the problem at the fish's head. Then you draw the spine and add major bones for categories. In manufacturing, you'll often see the 6 M's. Manpower, methods, machines, materials, measurement, and Mother Nature. In software or services, you can tailor categories such as people, process, technology, data, external dependencies, and monitoring, for example. Now brainstorm, add plausible causes as smaller bones. Then deepen the analysis by asking why on a branch, almost like mini 5 whys inside each category. Finally, don't stop at brainstorming. Fishbone is a hypothesis map, not proof. You still need to prioritize. Which causes are most consistent with the evidence? Which are most impactful? Then validate with data, tests, or controlled experiments. Fishbone shines when the problem is messy and cross-functional. It forces you to look beyond the obvious technical failure and consider process, training, communication, vendor issues, and measurement gaps. It's also a strong meeting tool. Everyone can see the same map, and quieter team members can add causes without fighting for airtime. The weaknesses. If you aren't careful, Fishbone becomes a beautiful poster of guesses, a laundry list with no prioritization. And without good facilitation, people will dump causes into their favorite category and move on. The fix is to pair Fishbone with evidence and a clear next tests list. For our checkout outage, a tailored Fishbone might look like this. Technology: DB connection limits, cache misses, thread pool saturation. Process: no pre-sale load test, scaling checklist missing. People: on-call handoff gaps, unclear ownership of DB settings. Monitoring: alert fired late, no SLO on checkout latency. External: payment gateway latency spike. From that map, you might prioritize 2 tests. Confirm connection pool settings versus expected traffic, and replay flash sale load and staging while monitoring DB connections. Our third method is fault tree analysis, or FTA. This is the most formal of the 3, and it's common in high-reliability fields because it models how a system can fail using logic. You begin with a precisely defined top event, your failure. Then you ask, what immediate conditions could cause this top event? You connect those conditions using logic gates. An OR gate means any one of the inputs is enough to cause the failure. An AND gate means multiple inputs must occur together. You keep decomposing until you reach basic events you can control or measure, like DB connections exceed limit, auto-scaling disabled, or payment provider latency above threshold. If you have reliability data, you can estimate probabilities and identify minimal cut sets, which are the smallest combinations of basic events that can produce the top event. The practical payoff. FTA makes interactions visible. It tells you where adding redundancy, monitoring, or protective controls will most reduce risk. Fault tree's advantages are rigor and clarity. It's great when failure depends on combinations. 2 or 3 things must go wrong together. It also supports what should we invest in decisions, especially when you can quantify failure rates or exposure. The trade-offs. Building a good tree takes time and a facilitator comfortable with logic modeling. And if you only model hardware and software, you can accidentally ignore human and process contributors, so you must intentionally include them as basic events when they matter. Here's a simplified checkout tree. Top event: checkout unavailable. Or gate to 3 branches. 1. App tier down. 2. Database unavailable. 3. Payment dependency fails. Zoom into the database branch. And gate combining, connections reach max, and no automatic shed/scale action. Those might decompose to pool misconfigured or traffic exceeded forecast, and auto-scaling policy disabled or no circuit breaker. A high-leverage control point might be: enforce pool settings via config as code plus an automated pre-sale load test, and add a circuit breaker that sheds non-critical work when DB connections spike. Let's wrap up with a simple chooser. If you need a quick first pass and the problem looks linear, start with 5 whys. It's the fastest way to turn a vague complaint into a specific testable cause and a countermeasure. If the problem spans teams, has many plausible contributors, or you suspect multiple causes, use a fishbone diagram to widen the search in an organized way. Then prioritize and test the top branches. If the stakes are high or failures interact, meaning you need to show exactly how combinations create the top event, fault tree analysis is the right tool. It's slower, but it's the best at revealing two things must fail together scenarios, and where controls reduce risk the most. In real life, the best RCA is often hybrid. Fishbone to brainstorm, 5 whys to drill down on the best branch, and FTA when interactions matter. That's it for this video. If you learned anything, please remember to give us a thumbs up and subscribe. And until next time, be careful what you click.